All right, today we're going to look at section 3.5. It's titled Analyzing Arguments with Euler Diagrams. That is how you pronounce that name. It's a mathematician named Euler. And to start with, we're going to just describe what are meant by valid and invalid arguments. Because that's really what we're assessing today, is we're going to have a different kind of diagram structure to decide if arguments are valid or not. So valid arguments are valid when all premises are true and it then forces the conclusion to be true. And then if something is not valid, then it would be called invalid. Another word that we will see used, but more in section 3.6 instead of invalid, is the word fallacy. So invalid and fallacy mean the same thing. They're just used interchangeably. And we're going to be using what are called Euler diagrams today. And they're going to feel a lot like Venn diagrams. In particular, we're going to see circles showing up in these diagrams. There's three different basic structures that an Euler diagram can take. One structure looks like a circle embedded inside of another circle. Okay. A second structure is there can be circles that overlap, so that looks like our Venn diagrams that we saw mostly. And a third structure is that we can have, those are supposed to be disconnected, I'll move it, disconnected circles. So these are sort of case 1, case 2, and case 3. And the argument structure, the way it's given, determines which of the three cases we're in. So I'm going to give you an example of the argument structure that sort of precedes creating any one of these three diagrams. So the first one we're going to do is going to be all dogs are animals. So the key word really in this is the word all. When you see the word all, it creates these kind of embedded circles, right, one inside of the other. Now, the circle on the inside is the first piece of the description, in this case, dogs. So everything inside this circle are dogs. And then the outer circle is the second part of the description, in this case, animals. Now, sometimes you can abbreviate, like if there's more verbiage with it. We'll see some examples of that today. Sometimes we almost sort of expand the description because it sounds a little funny the way that we would write it if we just use the exact words that are there. But we've got all dogs are animals. And what this is like a nested circle series, right? So it's like the nesting Christmas dolls, right? Like the Santas. The circles are inside of the other circles. So the reason that this works is because my circle for dogs has to be contained completely inside the circle for animals, because it says that all dogs are in fact animals. So I can't put the picture like this, because then the dog circle and the animal circle would not actually show all of the dogs inside of the animals. All right. Let's do another one. Let's do the middle one. So the middle one's keyword is the word some. Okay, so we get the word some. Some people are quiet. So one of the categories, one of the circles, is going to be people. And the other category is going to be, right, like quiet, but quiet's an adjective, so that sounds kind of funny. So you might throw the extra word in like things. Quiet things. Right, libraries would be one of those things, but obviously a library is not a people, but it's a quiet thing. You might throw in there snow, not ice. Ice is kind of loud. Snow is quiet, so that would be quiet things. So there's this overlapping piece where things, the people in this part are the quiet things in this part. This overlaps. These are the quiet people in the middle. Maybe you're one of them, maybe you're not. Every child in my house is not in this category, by the way. They're not quiet people. Okay? So anytime we see the word some, we're looking at overlapping circles. Any idea what the last one might be as a keyword? None or no, yeah. So we're going to use no for my example. So no hamsters. Live at my house. They don't overlap, right? They're in no way, shape, or form connected to one another. So these are my hamsters. They live lots of places, but the place they don't live is at my house. So again, you could put things that live at my house or something like that. I'm just going to say things at my house. Right, there's no hamsters there. I realized this morning as I was showing all my examples that I never created actually an example of number 3. So I'll create one at the very end as an additional example because I do want to make sure you see an example besides just this, sort of descriptive phrase at the beginning of one that's used in an argument. Okay, so I'm going to flip the screen and I want us to talk about the structure of the way these are set up to start with. Okay, so the directions say to decide whether the argument is valid or invalid. And what happens is they give us 3 sentences generally. Sometimes they might give us more. We'll have one example where they give us more. The first 2 sentences are givens. These are given statements. They're assumed to be true. And the question is does this follow? In other words, if the first 2 things really hold and they're always true, or whatever the structure is, they really work, is it necessarily true that then I can make this last claim? Can I for sure say the last statement? You're already jumping ahead of me, so hold on tight. We're not looking at this one specifically, but does that make sense in terms of the structure? The first 2 statements are givens. We assume them to be true, and the last one is, does this necessarily follow? And they're all set up like this, right? So we see 2 statements here, and then we see this line, and the question is, does this naturally then follow? Does it have to follow? Okay? So what we're going to do as we make these decisions is that sometimes my math lab will give you this question. It's just going to say, decide if it's valid or it's invalid, right? And so this is probably going to be one of those ones where if you say valid and you're wrong, then it's going to give you a brand new question to start over because obviously there's only 2 choices, right? 50-50. But they also might actually ask you to identify which of the following Euler diagrams fits this picture. So we're going to be looking at the Euler diagrams in hopes that we're going to use them to make an accurate, valid, or invalid statement, and we're not just guessing 50-50 or trying to reason through it. Some of them are easier to reason through than others. So you might look at this one and guaranteed, no, it works, it's valid, or it doesn't work, it's invalid. But we want to make sure that we have a structured way of deciding when things are not quite so obvious. That's what the Euler diagrams are looking for. So to start with, we're going to do each sentence one at a time. So when I told you these 3 different structures right here, right, and I have my 3 keywords, all, some, and no, every diagram's first sentence and second sentence are going to have some connection to these sort of descriptions. So our first sentence here says, all politicians lie, cheat, and steal. So the question is, do I have embedded or nested circles? Do I have overlapping circles? Or do I have disjoint circles for the first sentence? The concentric ones, right. The embedded circles, the ones that are nested. So I'm going to start with making a picture, make it a little bit bigger, where they're one inside of another. And how did you know that, Bren?
Because it says all.
Because it says all, okay? So that word all is the trigger for us to draw the concentric circles. Okay, the first part of the statement is what goes in the center of the first circle, or the embedded part, right? It's politicians. So right inside of here, we've got politicians. All right, so sometimes we have to restructure our languages as an example of one. I mean, the outer circle, what is it?
People who lie, cheat, and steal.
Yeah, so it doesn't actually say people, but that's what it means, right? So if you want to abbreviate it and just write lie, cheat, and steal, that's fine. But what it really is it's people who do that. People who lie, cheat, and steal are in my outer part of my circle. Okay, so what we've done is we've taken care of rewriting or drawing a diagram for the first one. Does that piece make sense? Okay, the next one says that man. So what typically happens at some point in the argument, and it's usually the second sentence, is that it identifies a specific person or people or, creature or something, and that's the object we're talking about. And what we're going to do is we're going to actually give that a name, and we usually give it the name X. It's really not so much a name as it is going to represent a location where this particular object sort of resides in the argument. So in this one, X is actually that man. Okay, so it says that man lies, cheats, and steals. So where could that man be in this diagram?
Outside of the politician, but inside of the lie, cheat, and steal.
Okay, could be right here. Could he be right here? Could be, right? We don't know that he is based on what we're given in those first two sentences, but could be, yeah? So he has two possible locations where he could reside. He could be a politician who lies, cheats, and steals, or he could be somebody else who lies, cheats, and steals. We don't really know. All we know is that he lies, cheats, and steals. Does that make sense? Okay, so the question is then, after I create all of that, and I've created those two pieces, can I for sure say that that man is a politician? No. Could he be? Yes, but can I make the claim that I know for sure? No. So this would be considered an invalid argument. So again, the first two pieces above the horizontal line are given guaranteed information pieces we know. The last piece is the question of, can I for sure say this is now true? And on this one, I can't. It's an invalid argument to say that I could. Okay, so we're going to try another one. Same directions. Some nurses wear blue uniforms. D. Boyle is a nurse. Therefore, D. Boyle wears a blue uniform. So we'll start with our first sentence. What type of circles do I have based on some nurses wear blue uniforms?
Overlapping.
Yeah, the overlapping ones, the ones that look like the ones we saw in our Venn diagrams, you're right. So we have overlapping circles. How do I know? Some. What are my overlapping circles? Close. Nurses is one. People, or anybody who wears a blue uniform, okay? So I'll say people who wear blue uniforms. All right, so would include other people besides just nurses, maybe doctors, maybe the postal worker, maybe the clerk at Wendy's, I don't know. I mean, anybody else who wears a blue uniform would be potentially over there. And there's this overlap that includes both of those groups, right? The nurses who really are wearing the blue uniforms, right? These would be nurses out here who are not wearing blue uniforms. And these over here would be people who are not nurses and who are wearing blue uniforms. Does that make sense? Our first sentence gives us that Euler diagram structure. Second one says D. Boyle is a nurse. So D. Boyle is our specific object or persons that we're talking about, right? So we're going to write it down that way with X. X is D. Boyle. Okay, everybody good with that? Okay. So it tells us that D. Boyle is a nurse. So what are my options, or where could D. Boyle's X end up being located?
Anywhere inside the nurse's circle.
Okay, anywhere inside the nurse's circle. So Isabella, here is good, and here is good, right? Yeah. So D. Boyle could be in either of those locations because all we know about D is that she's a nurse. And both of those areas of my diagram are nurses. Okay, she can't be over here, according to the information I'm given. She's not in this side that I have not put her in over here with the uniform people, right? Just the blue uniform parts. Okay, so we have taken care of the possible locations for D. And then our last one says, D. Boyle wears a blue uniform. Do I know for sure, based on this diagram structure, that D. Boyle wears a blue uniform? No, could she? She could. She could be in the overlap, but she doesn't have to be, right? So is it a valid argument? No. This is invalid as well. I promise they're not invalid. All of them invalid.
So the
Just
only
the
way
first
for it
two.
to be valid would be if it said all instead of some.
Hold tight. We'll see one. Okay? All right. Let's look at number 3. Number 3 says, all disc jockeys play music. So how will I draw my first set of circles that I'm talking with? Embedded circles. Okay? What is the inner circle? The disc jockeys. I'll just abbreviate it as DJs. And then what is my outer circle? People or things or whatever that play music, yeah. So I'm going to put people, just because we're talking about the disc jockeys that are inside. So people who play music. So it makes sense, right? There are, because the way that this is structured, the idea that there are people who play music who would not necessarily be disc jockeys. Agreed? Right. In fact, probably some of you are them. Agreed? Play music. Okay? But you're not in the disc jockey circle, perhaps. So that's our first one. The next one says, Flash Phelps is a disc jockey. So we're going to let X be Flash Phelps. Okay, everybody good so far? Okay, where could the X for Flash Phelps go?
Inside the disc jockey.
In here. And there is no other place I could put the X, right? So on the last two examples, and it's not always just because of where I can and can't put it, but I had more than one location. So sometimes I have a couple of locations where I can put things. Sometimes I don't, and I just have one location where something ends up. Now that does not necessarily mean whether something's valid or invalid. It's just worth noting that you can't just decide, oh, I always have one or I always have two. It doesn't work like that. It changes based on the structure of the wording. This one had only one. Now we've created our first two pieces of our diagram, and our question is, do I know for sure that Flash Phelps plays music? I do, because the inner circle, which includes Flash Phelps, is guaranteed nested inside of the outer circle, which is all the people who are playing music. So I don't want you to think that this is valid because there's only one location for X. It's valid because the X happens to also now reside in the circle that's larger, which is the circle I'm describing, right? The people who play music. So this is a valid argument. You okay, Jacob?
Yeah,
All right.
I was just like thinking, because like we did this in philosophy too, and like now in math, and we're doing this in things.
Yes, philosophy and math overlap. Who knew, right? Who knew? All right, any questions so far? Okay, so many of your problems can look like these, right? They're asking you to decide if something's valid or invalid. And what you're doing is you're creating a diagram in order to make such a decision. Okay? We're going to kind of flip it around now. We're going to be given a diagram, and we're going to create some kind of a structure of language that might be a fitting argument that could be made. Okay, so we're actually going to be creating a valid argument with our description. We're not creating something that's invalid, right? So we have to talk about the structure of the circles, right? One of our sentences. We have to talk about the X and what it's representing and how it's being described. And then we have to make a claim that we think we can make based on the structure of everything else that's true, right? A valid claim. All right, so somebody tell me about this circle structure. What kind of a statement might I be able to make about the pet lovers and the cat lovers? Okay, an all statement, I think is what I heard. Okay, what will my all statement say? Yeah, so we always start with the inner piece, right? All, in this case, cat lovers are pet lovers. Now, it's important for you to sort of be aware of the fact that you might not even have to agree with the statement that's given. It's just the statement structure of the picture, right? You might be like, well, I don't know. I know this one person. We're not talking about whether or not you think it's true or false, right? We're talking about the structure of the picture. And this is the structure of the picture. The picture says all cat lovers are pet lovers. What about the X? What is that sentence going to give us? What sentence should we have?
Jessica Long is a cat lover.
Good. Jessica Long is a cat lover. Okay, does that make sense? Everybody good? Okay. So what conclusion might we decide to come to based on those two pieces of information that would be valid? Right. Jessica Long is a pet lover. And this does feel a fair bit like the one over here with Flash Phelps in it, right? It does end up feeling a fair bit like that one. I had somebody in my earlier class ask, well, does it have to say cat lover? Could it just say loves cats? It could, right? Like, we've changed sort of the verbiage or added the word people or abbreviated DJ. There's differences in that can show up, and that's not a big deal. So just be aware that if you're looking at that the exact language is not the point. It's the intent behind it. Cat lovers and loves cats are the same thing. Okay? All right, I want to do one more simple example before we get to the last one that's rather complicated, because I don't have an example of the one that says no. Okay? So just add this to the very end or add this to the side of the page you're on. It doesn't matter to me. I'm just going to create an additional one. So what number were we on? We'll call it 4B. All right, so we're going to create the example, no infants are adults Joey is an infant. Therefore, that's what that line is, remember, therefore, Joey is not an adult. Okay, so you see a lot of negation kind of language in it. No and not show up on this one. Okay, so the word no at the beginning tells me something about my circles. What does it tell me? They don't overlap. They are separated from one another. They are disjoint. Something like this. What are those two circles?
Adults and infants.
Yeah, adults and infants, in whichever order you wish. One's adults and one's infants. Okay, so that takes care of sentence number one or statement number one. How about my second statement? Joey is an infant. What would I do?
X and infants.
Yeah, so we're going to let X represent Joey, right? X is Joey, and where am I going to put it? In the infant circle. That's what the second sentence says. Joey's an infant. So can I say this statement that follows? Is it valid? Joey is not an adult. Yeah, I can, right? So I can say that this is a valid argument. Okay, is that all right? Okay. Okay. Last example. So tell me why you might think that this is a little more complicated than the rest. What are some red flag things? Okay. There's 4 sentences instead of 3. There's flat out just more statements. Anything else, Isabella?
There's all statements and some statements.
There's an all statement and a some statement. So this one is going to be more complicated for both of those reasons. I mean, those are the primary things that you see showing up here, okay? So as we start the first sentence, however, it is very much like the ones we've seen before. It says, all people who drive contribute to air pollution. Okay, so again, I don't care whether you think it's true or false. That's not the point. The point is to create a structure, a diagram that represents the sentences that were given. So what kind of circles are these going to be? Concentric. So I'm going to have a small circle inside of a larger one. What is the descriptive phrase or words or whatever that I want to put in the inner circle? Yeah, the smaller one. Yeah, the people who drive. So that's always the first piece, right? The one right after the word all that goes on the inside circle. So these are the people who drive. So that's probably most, or if not all of you, people who drive. So according to this first statement, what is the outside circle?
People who contribute to their solution.
Yeah.
Things.
Yeah, the people or things, however you're descripting sort of works with the phrases that follow. I'm going to use the word people. So these are people who contribute to, and I'll abbreviate air pollution with AP. Okay, so when we've got multiple statements, just take them one at a time and move through them. So this first one's done. Now the second sentence says, all people who contribute to air pollution make life a little worse. So I hope you see that there's another all. And all means I'm going to have concentric or embedded circles, right? That's what it means. So notice this first statement, however, the people who contribute to air pollution is already in my diagram, isn't it? I already have a circle representing that. But looking at this sentence, it tells me how it's going to relate to the next piece. Yes, Trey?
So do we need another circle?
We do need another circle. Where do you think the other circle is going to be in this diagram? Yeah, around the people who contribute to air pollution, right? Because I need an embedded circle, but my embedded circle has to be containing the people who contribute to air pollution. In other words, the people who contribute to air pollution is the inner circle for this new outer circle I created. What is this new outer circle I created representing?
People who make life worse.
Yeah, people who make life worse. So by very nature of description, in the way that this is worded anyways, we have this sort of idea that there are some people who make life worse, but maybe it has nothing to do with air pollution, right? That's the sort of outer layer of this embedded donut thing we've got going on, right? We have some idea that there are people who contribute to air pollution who aren't necessarily driving, right? Maybe they're contributing to it in some other fashion. We think we would have the idea that not everybody who is making life a little worse happens to be people who are driving, right? Because the driving is this little circle, and then there's this extra space for other people to be. All right, so what happens next is very interesting. While I do see the word some for some people, the some people is very much like encountering, well, that was one of them, Jessica Long, or Flash Phelps, or D. Boyles, or that man. Okay? The some people are the object, the X, that I'm looking for at this point. So, even though it's got the some people as the description and it's got that keyword some, the X that I'm talking about here, actually let me use a different color just because it'll be easier to distinguish. X is going to be the some people, but I need a little bit more. It's not just some random people. It's some people who do what?
Live in suburbs.
Yeah, live in the suburbs. So some people living in suburbs. Okay, so some people living in suburbs is my X, and it says some people who live in suburbs make life a little worse. So where do we for sure know X has to be?
Somewhere inside the biggest circle.
Somewhere inside the biggest circle, right? Somewhere in there. Does that make sense? But we don't necessarily know where. So X could be in here, or in here, or in here. You could actually write the X in all those locations if you wish, but we don't know, but it has to be somewhere in one of those three, or maybe in multiple ones of those three, right? Maybe X actually is in the makes life a little worse, because there's some of them that make life a little worse for some other reason, and some of them are going in the drive circle too, right? Like, we don't know. But it has to go in one of those locations by the description that we've been given. But we don't know which one for sure. Does that make sense? So let's take a look at the last statement then. The last statement says then that some people who live in a suburb drive. Now, that may or may not be true. That's not the argument, right? The question is not whether it's a true statement. The question is whether you can make a valid claim based on the previous statements. Do I guaranteed know that the some people are in the drive category in the middle? I don't, right? I for sure know they lie in the people who make life a little worse area, but I don't know for sure that they're all the way inside of the drive circle. Could they be? Sure, they could be, but they don't have to be. All right, so some people, even though it just says some, and we got some and some not, and that's not, it's acting very much like a single person. Joe lives in a suburb. This could very easily say, Joe makes life a little worse. He lives in the suburb and he makes life a little worse. Okay, well, but I don't know where he actually falls. We know he lives in a suburb. That's his descriptive phrase, who he is. He's a suburb person, right? But the fact that is that we don't know where inside the people who make life a little worse he is. Is he in the very center in the drive? Or is he just in the outer ring? Or somewhere in between? So this argument would be considered invalid. Yeah, invalid because we don't know for sure that he's in the middle. Because he could be in any of those three locations and not have to be in the very dead center. Okay, this is the hardest one. Most of them are far more like the others that we did. Any questions on that? Okay, you should be able to do the homework for 3.4 and 3.5 inside of Unit 4. We're on Unit 4. Don't do the quiz until we get through with Unit 6 or with Section 6, which will be hopefully Wednesday, but maybe Friday. Okay?